The next step is to go to the library and search for the kind of information he's looking for. This is a very time-consuming step. If he finds some data, usually he will find more than one result, and those results will not be the same. He then has a task of deciding which is the most reliable value to use. Now, it's very seldom that the man who wants to use that data is an expert in the data. And if he tries to evaluate the data to decide which is the best value, he is unlikely to produce a reliable figure. Now, another way in which the reliable data help the engineer are through enabling him to reduce the tolerances in his design. By having reliable, evaluated data, he's enabled to cut those tolerances down and save time, material, and money. A third way the data help this engineer is by enabling him to design a process with more confidence that it's going to do what he thinks it's going to do. Dr. Talukian, we view critical data evaluation as part of the process of basic research. Evaluation of data can really only be done by a man who is knowledgeable about the experimental techniques, knowledgeable about the theory, so he can compare the results with what should be expected, knowledgeable about the sources of uncertainty in the experimental measurement. So it takes a high level of professional skill and sophistication to evaluate data properly.
At the time this film was being made, the 5th International CODATA Conference, an international symposium on the numerical data of science and technology, was being held on the campus of the University of Colorado at Boulder, under the auspices of the U.S. Academy of Sciences. One of the key participants of the conference was Dr. Louis M. Branscombe, Vice President and Chief Scientist at IBM. He's a member of the International Council of Scientific Unions and a former director of the National Bureau of Standards.
Each scientist has a different motive when he sets about exploring a question. And unfortunately, rather low in his list of motives is to produce numerical values for someone else to use in an engineering application. As a result, the scientist may be much more interested in the trend of his data with some parameter like temperature or pressure rather than the absolute values. And it's easy for the engineer to be deceived when he looks in the literature and he sees the data quoted with an absolute value scale and assumes that perhaps a great deal of attention has been given to that normalization. In fact, that normalization may be simply for the convenience and the appearance of the diagram. And you have to read very carefully, sometimes unfortunately between the lines, to find out precisely how the data were calibrated and normalized. Engineer can almost never escape the need to be on solid ground with respect to absolute values. Science and technology are no longer a luxury for the amusement of scientists and engineers. They're vital to the well-being of society, and that means that it is not nearly as difficult as it once was to put one's work on a very quantitative basis, to make a diagnosis of all of the possible environmental effects on a measurement. If you have a computer-controlled measuring system, your apparatus can sometimes track 12, 15 parameters instead of the 1 or 2 that a manual experiment might do. There is a lot of sloppy work in the literature, and in the old days it didn't all get found out for a long time. And with conscientious, scholarly people very carefully examining the literature and sorting out the carefully done work from the hastily done work, I think the standards of science itself will be improved.
By now, it should be clear that we do have inaccurate and erroneous data in the literature, and unfortunately, they represent the majority of the cases. However, one can only become aware of the discrepancies by setting all the related data side by side and comparing them. This is the function of CINDAS, to systematically collect and evaluate all the available data in its field. In data evaluation, one may find at times that none of the existing information is acceptable. One good example is the thermal conductivity of copper. We see here nearly all the data available in 1964 for temperatures above 100 degrees Kelvin. It was concluded at the time, however, that none of the data correctly represented the thermal conductivity of high purity copper. CINDAS predicted those values, shown here by the solid line. 3 years later, in 1967, this predicted curve was fully confirmed by new and accurate measurements. CINDAS not only evaluates the existing information, but also fills important gaps through the process referred to as data synthesis. Good examples are these data on the refractive index of sodium bromide. From these fragmentary data, CINDAS has used its techniques of synthesis to generate a complete mapping of reference values that covers the full range of wavelength, an almost hopeless task for the experimental laboratory. Similarly, the fragmentary and insufficient experimental data on the electrical resistivity of aluminum-copper alloys have been transformed into a full range of recommended reference values through data synthesis. Chances are that you are seeing these results for the first time. Considering that the majority of data is generated by seasoned experimenters, you may be asking, why do such disagreements and gaps exist? The answer is an elusive one. Poor material characterization? Undetected systematic errors? Any number of reasons. One thing is clear, however, that old handbook, the hot literature value in your file, or your helpful office mate, these are not always the reliable sources you may think they are. CINDAS is reliable. It can help you in many ways. If you need original data from the open literature, the Center publishes a retrieval guide, which lists the total contents of its bibliographic banks in a unique printed format. Bibliographies are also available on magnetic tapes. CINDAS can provide microfiche or hard copies of any document it lists in the retrieval guide or tapes. If you want evaluated data, CINDAS may refer you to the proper volume of its comprehensive reference data series, if such is already available. If not, the Center can use its powerful analysis and synthesis techniques to recommend reliable values. Why not join the hundreds of engineers and researchers who have learned from bitter experience that it does not pay to play the numbers game? Even if you think you have the information you need in your files, it may represent only one of these scratches. Your work is too important not to use the best of data. Reliable, evaluated information does not cost. It pays.